Today we are doing lesson 5.1, ratios and rates. For our I can statement today, I can find ratios, rates, and unit rates, including ones involving fractions. All right, so for our first example here today, we are writing and simplifying rates and ratios. So for the first one here, the first situation, it says there are 45 males and 60 females in a subway car. The subway car travels 2.5 miles in 5 minutes. Find the ratio of males to females. So when we write ratios, we look at the same order that's in our words. So here it says we need males first and then to females. So 45 to 60. And for ratios, there's actually 3 different ways to write it. You can write it 45 to 60 with a colon. You can write it with a fraction bar, 45 to 60. And then you can also write it with the word 2to, 45 to 60. All right, so no matter which way you write it, you think about it like a fraction and simplifying a fraction. So you are dividing on both sides by a common factor, just like if you were simplifying a fraction. So 45 and 60 can both be divided by 15. 45 divided by 15 is 3. 60 divided by 15 is 4. So our simplified ratio, 3 to 4, and then we need to put our labels back in. So 3 males to 4 females. All right, and then it says find the speed of the subway car. So when we find speed, that's a rate. So we don't need to simplify it to whole numbers here. We need to figure out how much for one thing. So for our speed, time is always second in speed. So here I'm going to do 2.5 miles in 5 minutes. Usually with speeds or any sort of rate, you see it in fraction form, or ratio, you can really write it in any of these forms, but usually for rates, you see them as a fraction. So what this means is 2.5 miles for every 5 minutes. And we have to figure out how much for 1 minute. So in order to do that, we're going to divide this out. This is actually a division problem. 2.5 divided by 5. So I'm going to do that work off to the side. 2.5 divided by 5. 5 goes into 2 0 times, but it does go into 25 5 times. 5 times 5 is 25. So my rate here is going to be 1/2 or 5/10 miles for 1 minute. So I can write it this way, 1/2 miles for 1 minute. You could also write it like this, 1/2 mile / minutes, or per minute, or for 1 minute. There's always a lot of different ways to write with a rate, but you do have to have both labels as part of your answer. All right, so for example 2, it looks at some information in a ratio table. Ratio tables show a multiplication or division pattern between their columns or rows. So here, this ratio table shows the cost for different amounts of artificial turf. And they want you to find the unit rate in dollars per square foot. So dollars per square foot, they're telling us that the square foot, whatever the second one is the one they want to be 1. So the way that they have it set up right now, they're multiplying by 4. But we need to work backwards, and we have to use a multiplication or division pattern in a ratio table. So if I'm going to work backwards here, 25 to 1, I would have to divide by 25. Things only stay proportional. Those ratios only stay the same if you multiply or divide. It won't work for addition or subtraction. So we're going to divide, 25 divided by 25 is 1. So then we do 100 divided by 25, and that gives us 4. What that means is our unit cost is $4 per square foot. And again, your final answer needs both labels, dollars and square feet. This time I'm going to use the word per, but I could use the for 1 foot, square foot, I could use a slash, but I do need both labels in my answer. All right, so for our next 3 here, in example 1, find the ratio of females to males, find the ratio of females to total passengers, and then find your speed for miles per second based on this table. So go ahead and pause the video and go ahead and try these problems on your own. All right, so let's go ahead and check our answers. So first one, we're doing females to males. So if I go back here, females 60, males 45. When I divide by 15, I get 4 females for 3 males. All right, in example 1, find the ratio of females to total passengers. To get the total, we have to add our numbers together. So we said that there were 60 females and 45 males. That means altogether it is going to be 105 people. So 60 females to 105 total people. All right, and then let's see. I believe 105 is divisible by 15. I guess I should double check that before I start going to simplify over here. I know 60 is divisible by 15. So let me think. I think that's going to be 7. Let's double check that. 5 times 7 is 35. 7 times 1 is 7. Plus 3 is 105. Yeah, 7. Okay, so when I divide both of these numbers by 15, because again, ratios need to be simplest form, I get 4 females to 7 total passengers. All right, and then for this last one, number 3, we're using this ratio table. They want us to find the speed in miles per second. So the second label per second, that's what they want to be 1. And a rate, whatever the second label is the one that needs to be 1. So miles per second, I'm going to change that into 1 second. And then we don't know how many miles. So we're looking at our multiplication and division patterns here. To get from 3 to 1, we would have to divide by 3. So we're going to have to do 14 and 4/10 divided by 3. I am going to need to do that off to the side because that's not something I know off the top of my head. Let's see. 3 does not go into 1, but does go into 14 4 times. 4 times 3 is 12. 14 minus 12 is 2. Then we're going to bring down this number. We're going to bring up our decimal. 3 goes into 24 8 times. 8 times 24 is 24. We subtract and get 0. So our answer here, our rate is going to be 4 8/10 miles per second. All right, so on our next one here, we're going to do a rate using information from a table. So the graph shows the speed of a subway car. Find the speed in miles per minute. This is the order they want us to divide, miles per minute. And then we need to compare the speed. So they're asking us to do two things. First thing is to find our rate, and the second one is to compare our speed. Okay, so first thing we're going to do, find our speed, miles per minute. So miles is going to go on the top. Minutes is going to go on the bottom. All right, so if I look at my line graph over here, they tell us minutes is on the x-axis. When we have an ordered pair, let's see, I'll write it up here. Our ordered pair always gives us the x information first and then the y information. So I'm going to pick this first point, 1/2 and 1/4 to use. The first number is our minutes number, so that's 1/2. On our rate, it's going on the bottom because it said miles per minute. And then our second number is our y, which is miles, so that's going to be 1/4. So our compound fraction here is 1/4 mile for 1/2 minute. So this means 1/4 divided by 1/2. It looks tricky, but it's really just a different way of writing division. So I'm going to rewrite it horizontally, 1/4 divided by 1/2. We're going to do keep, change, flip, 1/4 times 2/1. All right, I'm going to go ahead and just multiply straight across. 2 times 1 is 2. 4 times 1 is 4. We're going to simplify these by dividing by 2. 2 divided by 2 is 1. 4 divided by 2 is 2. So I have 1/2. I have to keep my labels the same as what they are here, miles. Per minute. Okay, so we did the first step. We found the speed in miles per minute. Now I need to compare the speed to the subway car in example 1. So I'm going to go back to example 1, which was this first one. Our subway car, remember, was 5/10 miles per minute. And now I have 1/2 miles per minute. So that's going to be the same. 1/2 and 5/10 are the same. So I'm going to write the speed is the same as the subway. In example 1. All right, number 4, you use the point 3, 1.5 to find the speed of the subway car. Does your answer change? Explain your reasoning. Go ahead and pause the video and try this one on your own. Okay, let's check our answers. So remember, it's going to be miles per minute, so miles goes on the top, minutes goes on the bottom. When I go back to my picture here, 3, 1.5, 3 is our x, 3 minutes, 1.5 is our y, miles. So here I'm going to do 3 minutes on the bottom, 1.5 miles. And I need to divide 1.5 divided by 3. So if I write it out this way, 1.5 divided by 3. With fractions, I need to make them improper if I have a mixed number. So 2 times 1 is 2 plus 1 is 3. 3/2 divided by, and then I have 3/1. We're going to do keep, change, flip. 3/2 times 1/3. All right, I'm going to go ahead. I'll cross cancel on this one since I haven't done that strategy yet today. 3 divided by 3 is 1. 3 divided by 3 is 1. I'm going to multiply straight across. 1 times 1 is 1. 2 times 1 is 2. I get 1/2 mile per minute. This time I'm going to use a slash instead of the word per. Does our answer change? No. It is still 1/2 mile per minute. All right, let's take a look at our next example. This is definitely the trickiest type of problem in our lesson today. So we've got a ratio with a few different parts that we're going to compare. I'm going to show you two different methods for solving this type of problem. So here's the problem. You mix 1/2 cup of yellow paint for every 3/4 cup of blue paint to make 15 cups of green paint. How much yellow paint and blue paint do you use? So we have three different numbers to keep track of. We have yellow, blue, and then our total number of cups. So we are going to use the ratio table to keep everything organized. To get the total, which is our green, I'm going to just add green up here. You get green by mixing blue and yellow together. So we're going to add to figure out how much total paint is in one batch of paint. To do that, I need to find a common denominator on my fractions. So I'm going to change my 1/2 into 2/4. And then when I add 2/4 plus 3/4, I found out that one batch of green paint is going to be 5/4. But I don't want to know how much for one batch. I need to figure out how much when I have 15 cups of green paint. So to do that, I'm going to go ahead and multiply by my denominator, which is 4, to get my next row of numbers. I'm multiplying by 4 here to cancel out the fraction, and that's going to give me whole numbers to work with. It's going to be a little bit easier. So if I was going to do 5/4 times 4, my denominator cancels out. I'll show you that here off to the side. 5/4 times 4/1. 4 divided by 4 is 1. 4 divided by 4 is 1. 5 times 1 is 5. 1 times 1 is 1. So 5/1 is 5. Multiplying by that denominator gets rid of it. So instead of 5/4, when I multiply times 4, I now have 5. Same over here. If I do 3/4 times 4, cancels out the bottom part, leaves me with 3. 2/4 times 4 cancels out the bottom part, leaves me with 2. And yes, that is still true. 2 plus 3 does equal 5. So I know how much if I want 5 cups of green paint, but I want 15. So again, ratio tables are working with multiplication or division patterns. For this one, I'm going to need to multiply by 3. 5 times 3 is 15. So I need to multiply all of the numbers in this row by 3. Three times 3 is 9. 2 times 3 is 6. 6 cups of yellow mixed with 9 cups of blue. That is going to give you 15 cups of green. So my final answer is 6 cups of yellow and 9 cups of blue. All right, same problem, different strategy. So if you don't want to do it with the ratio table, here's how you could do it. So same problem, 1/2 cup of yellow paint for every 3/4 cup of blue paint. We need to make 15 cups of green paint. So we can take the information from our fractions and find a fraction of the total with one of them. So if I want to know how much yellow paint for green compared to green paint in one batch, yellow paint, remember, is 1/2 cup to start. But then to find out how much green paint for one batch, I have to add them together, which I did on the last slide, but I'll do again here. Common denominator, I've got to multiply by 2/2 to make that 2/4. Plus 3/4 tells me that in one batch of green paint, it's 5/4. 1/2 of yellow paint for every 5/4 cups green paint. And then this means divide, 1/2 divided by 5/4. So I'll do that over here, 1/2 divided by 5/4. Keep change flip becomes 1/2 times 4/5. This time I guess I'll just multiply straight across. 1 times 4 is 4, 2 times 5 is 10. When I simplify that by dividing by 2, I get 2/5. Okay. What that means is there's 2/5 yellow for every 1 cup of green. So now I have that 2/5, I can multiply that to figure out how much of the 15 is going to be yellow. So 2/5 times 15 over 1. I'm going to cross cancel here. 5 divided by 5 is 1, and 15 divided by 5 is 3. 2 times 3 is 6 cups of yellow paint used. And then I would have to subtract to figure out, well, if that's 6 cups of yellow, 15 minus 6, that means I have 9 cups of blue paint used. So some people prefer to do ratio table. Some people prefer to do fraction of the total. Either way will work, but of course, as always, it's very important that you're writing down your work for what you're doing. All right, let's see. How much yellow paint and blue paint do you use to make 20 cups of green paint? Go ahead and pause the video and try this last one on your own. All right, let's go ahead and try this out. So if I'm going to do my ratio table, I would still start the same way. Yellow, blue, green. We had 1/2 and 3/4, which equals 5/4, but this time I need it to equal 20. So we multiply everything by 4 to get rid of the denominators. Whoops. Got to change that back into my common denominator here before I multiply. So that gave us 2 cups of yellow. It gave us 3 cups of blue. That gives us 5 cups of green. And then this time to get to 20, I would have to multiply by 4 again. 5 times 4 is 20. 3 times 4 is 12. 2 times 4 is 8. So it's going to be 8 cups yellow and 12 cups blue. You have to make sure your two numbers always add to equal your final thing. It's supposed to add to equal. 8 plus 12 does equal 20. If I was going to do a part of the whole, we already found that the yellow was 2/5 the amount of the green. So we would do 2/5 times 20 over 1. I'll multiply straight across this time since I did cross products the last time. 2 times 20 is 40. 5 times 1 is 5. 40 divided by 5 is 8 cups yellow. And then we subtract from 20 to get the amount of blue. 20 minus 8 is 12 cups blue. So you can do it either way.